Hello students, welcome to Eshwari Thaniksha channel. Students, in this video we are going to learn super tricks to identify Arrhenius acids and bases, Bronsted Lowry acids and bases, and Lewis acids and bases. So totally there are three concepts which explains about acids and bases. The first concept is Arrhenius concept. In Arrhenius concept, what are acids? Acids are nothing but substances. When you dissolve in water, it should produce H plus ion. And what are Arrhenius bases? When dissolved, when a substance, if you dissolve in water, it should produce OH minus ion. Second concept is Bronsted-Lowry concept. In Bronsted-Lowry concept, acid is a substance which will donate a proton. Proton means H plus ion. And base is a substance which will accept the proton. So proton means H plus ion. So here you can see in Bronsted-Lowry concept, both acid and bases, it will be in terms of H plus ions only. Whereas here it is in terms of H plus ion and this is OH minus ion. So this differences you should remember. And third is Lewis concept. So in Lewis concept, acids are substances which will accept a pair of electron. So that is electron pair they will have to accept, and bases are substances that will donate electron pair. So these are the three concepts. Now we will take example and we will try to identify whether it is Lewis concept of acid and bases or Bronsted acids or bases or Arrhenius concept is followed. So first example is HCl, hydrochloric acid. So now three options are given. So you have to identify which is correct statement for correct option for hydrochloric acid. So first is Arrhenius acid, second is Bronsted acid, third is Lewis acid. So first we will see Arrhenius acid. What are Arrhenius acid? Substances when dissolved in water should produce H plus ion. So HCl, when you dissolve in water, it will produce H plus ion because it will dissociate into H plus and Cl minus ion. So therefore this acts as Arrhenius acid. Second is Bronsted acid. So whether it will donate proton? Yes, HCl will donate a proton. So it will form H plus ion and Cl minus ion. So therefore this is a Bronsted acid. Next is Lewis acid. So Lewis acid means it should accept a pair of electron. Whether HCl accepts a pair of electron, so HCl will not accept a pair of electron. Therefore, Lewis acid, this is wrong. So these two options are correct, but the third option is wrong. Next, we will go for second example. Sodium hydroxide. So three options you have. First option is Arrhenius base. Second option is Bronsted base. Third is Lewis base. So we will see first option, Arrhenius base. So what are Arrhenius base? Arrhenius base means when dissolved in water, it should produce OH minus ion. So sodium hydroxide, when you dissolve in water, it will produce H plus ion and OH minus ion. So this is producing OH minus ion. Therefore it is a Arrhenius base. Whether it is a Bronsted base means it should accept a proton. So whether sodium hydroxide accepts a proton, sodium hydroxide will not accept a proton. So therefore Bronsted base, this option is wrong. Third is Lewis base. Whether it is a Lewis base means it should donate a pair of electron. So sodium hydroxide will not donate a pair of electron. Therefore this is not a Lewis base. So only first option is correct. So we will go for third example. Third example is ammonia. So again we have three options. Whether it is a Arrhenius base, Bronsted base and Lewis base. So first is Arrhenius base. Arrhenius base means it should When it dissolves in water, it should produce OH minus ion. So here you can see in ammonia there is no OH minus ion, there is no oxygen at all. Therefore, this is not Arrhenius base. Coming to Bronsted base, it should accept H plus ion. So students, here you can see there is lone pair of electron. Therefore, if there is H plus ion, that will be taken by this lone pair of electron and it will form NH4 plus ion. NH4 plus. Therefore, it can accept a proton. Therefore, this is a Bronsted base. Third is Lewis base. Whether it is a Lewis base means it should donate a pair of electron. See whether it has a lone pair of electron. So here you can see there is a lone pair of electron. So ammonia can donate this lone pair of electron. Therefore, this is a Lewis base. So by this concept we can easily identify whether it is Arrhenius acid and base or Bronsted Lowry's acids and bases or Lewis concept of acids and bases. So students, I hope it is useful to you. So if you find it useful, you can share with your friends and also you can subscribe the channel. I'll meet you in the next video, students.